Hi, welcome to Forge and PowerBI APIs, Better Together. My name is Jaime Rosales, and I'm a Senior Developer Advocate for Autodesk. Here is my Twitter handle, AfroJME. So a little bit more about myself. I'm a Senior Developer Advocate, which is part of the Developer and Advocacy and Support team. I've been part of Autodesk for over 8 years, and I joined through the acquisition of BIM 360 Glue back in December of 2011, where I was part of the core engineering team focusing in the development of the plugins using the Autodesk AEC APIs. In 2014, I joined the ADN team in order to support customers using our desktop APIs. And also I started working with the Forge platform, before it was called Forge. I work helping customers adapt the platform from the technical and business side. I organize Forge accelerators, hackathons, and I also have been spending quite some time with the AWS team building a couple of solutions to automate the hosting architecture of your Forge applications running on the AWS cloud. For today's agenda, we will be focusing on PowerBi API. Is it only advanced dashboards? Autodesk Forge APIs. I know we can see cool 3D content on the web, but is that it? And then let me show you also some customer success applications from our Forge community, which are using a combination of both technologies. So let's get started with Power BI and its API. So like I said, Power BI is not only advanced dashboards. Power BI dashboards includes almost all kinds of ways to visualize reports, but also includes some interesting applications for a specific analysis produced by the community, one of which is the bubble chart we use in a lot of our integrated samples. It is very straightforward to build the data model in Power BI and connect with the data by manual, scripting, or by the use of the APIs. Most of the APIs are RESTful based, which are easy to integrate. The dashboards are highly interactive and also are linking each other very smartly. For example, with the same data source, various types of visual reports can automatically reflect the data which are clarified by one report, sometimes with no coding at all. And of course, more smart features can be achieved by the coding, for example, data mining and machine learning. So the Power BI service and the Power BI embedded service in Azure have APIs for embedding your dashboards and reports. When embedding content, this gives you access to the latest Power BI features, such as dashboards, gateways, and workspaces. So let me show you a small sample about an application that the Power BI team has created as an embedded playground. There are two main scenarios for the embedding Power BI content. Embedding for your organization's users who have Power BI licenses, and then also embedding for those users and customers without requiring the Power BI license. So for customers and users without the Power BI license, you can embed dashboards and reports into your custom applications, using the same APIs to either service your organization or your customers. Your customers see the application manage data, and also your organization's Power BI users have additional options to view their data directly in the Power BI framework or in the embedded application context. You can take full advantage of the JavaScript and RESTful APIs for you to embedding your content and successfully adding your needs. In this sample, we're visualizing how the embedding playground also gives you access to some code snippets. For example, you have different ways to select the embedding kind of report you want to generate. You can either do a view report, a create report, or an edit mode. What you're currently seeing is the edit mode report. So in that way you can start adding some of the other components that Power BI provides to you in order to later on create certain interactions, and also at the same time get those snippets of code for you to test directly on their playground. On the right side also, we see a log window, basically where we are adding information about what is going on with the selected interactions that we are selecting, for that matter. Later on, we can run code and then also get some kind of adaptive response to the different kind of screens that we have access today, where we are able to visualize the reports directly, let's say on a phone screen. And let's say also we want to run some command in order to print this as a PDF. We have all those interactions available directly into the embedded playground. And it's a little bit easier to just see the code work in order for you to adapt it to your application. So let's move forward. In this class, we will not talk about Autodesk Forge API in total, basically, but I will give you a little bit of a summary of what the Autodesk Forge API is. So Forge is Autodesk cloud platform development. The Forge platform is the set of web service APIs to help you build the next generation of cloud power applications. The Forge APIs help you tap into your design and engineering data in order to streamline and innovate how you work. Forge empowers software developers to build applications that can automate processes, connect teams and workflows, or visualize and analyze their data. At this moment, Autodesk does not currently provide any data connectors for Power BI, which will enable you to get the data into Power BI directly from a given Forge service. But without that, we will need to follow the next 3 steps in order to move that data from Forge to Power BI. So the first step will be we need to get that data out of Forge. The second step will be we will move that data into a database or a file format that Power BI supports. 3, we will connect Power BI to the data source. So if you think about it, the only Forge related part in the above process, it's getting the data out of Forge. And that will vary based on what data you need. You can get object properties from a model through the viewer or through the model derivative API. There are APIs also that allow you to get issues and other data out of BIM 360, for example. So you have to look at the specific Forge API in order to identify which kind of data you're going to need. In the following example, we will need to prepare the records of clashes and object properties. So clash data is provided by the Clash API of the Model Coordination Service. But how do we prepare that object properties on the server side? Although the Model Derivative API can provide the properties of one model, it will return a large amount of data with everything, and one document only per one call. So fortunately, the Model Coordination API also provides Index API. And as part of the SBF conversion process performed by the Model Derivative Service, the property data from the original seed file is extracted to a property database file. So the Model Coordination Indexing Service uses these files to create an index, which represents the merged property data from every model in the model set version. In another word, we can extract the properties directly by the Index API with, let's say, an S3 queried format from AWS. We can easily specify filter and which properties we need in the query result, and it will save us a lot of time to get expected data running at the backend. So the embedded Power BI container simply loads the report and renders the data in the browser. So updating the data of the report will refresh the views, and the embedded container can also be refreshed accordingly. I will recommend play with some dummy data records before you actually publish the template report. Another interesting feature that Power BI provides is also the export of data to an Excel file with the filter records that we are selecting. And for this, we will not need any coding at all. So moving on. The following diagram tells you about the workflow of the application that we just saw. With the raw clash data from the Model Coordination API, the sample creates a matrix view of clash objects between documents. It is like a grid view in the BIM 360 user interface. When the user clicks one pair of documents, the corresponding clash and object properties will be dumped as records. These records will be sent to PowerBI template, a data model with bubble charts, and a table view, which has been created in advance. After the records are injected to the PowerBI template, the embedded container of PowerBI in the web browser can be refreshed with the new records. Now the magic happens. And as I said, the PowerBI can analyze the data automatically. The bubble chart will present the clash by types, clustered by the two documents. When we click a category, all relevant clashes will be highlighted in the Forge viewer. Since the PowerBI dashboards are linked intelligently, the table view will be updated with the corresponding data, which are clarified in the bubble chart. The end user can now check the independent rows for one specific group of clashes. So let's talk now about some real-life scenarios from our Forge community partners. There are two customers that I would like to share with you today, and the first one comes from Roma, Italy, Blogic, who created Vcat. So Vcat extracts the data present in the BIM models and imports it into the PowerBI datasets, which are already linked to the individual elements of the file. The result is the possibility of having different PowerBI templates ready to be used in a few clicks. Focus on the analysis and management of assets or spaces with the added value of using the Autodesk Forge viewer. And the second one, it's Mycon. So based out of Norway, who have taken visualization of the Forge viewer to another level and also are big PowerBI users embedding the content directly in their SaaS application. So Mycon is taking advantage of high levels of engagement games have to offer, implementing this into the building workplace in the form of a digital twin in an intuitive interface for a superior user experience. So, the evolution of Bcat led to the birth of the Bcat integration for BIM 360, a direct integration between the world of business intelligence and Autodesk BIM 360. Using your BIM 360 account, you can generate a series of ready-to-use Power BI templates for each project in a few clicks, which will be already fully configured. We have a chance to do comparison of the templates between versions, 2D and 3D visualizations, and personalized customization, colored applications suitable for every need. And that was Vcat from Blogic. And the next one will be Mycon. And Mycon actually shared a couple of snippets of code of the libraries that they use in order to integrate with Power BI into their application. They use the Power BI client NPM, which can be installed directly into your application via NPM, or also it can be found on Bower. So the position of the pop-ups like this, they end up using the Windows request animation frame for every frame that they add into their application. The file that we want to focus on is the powerbi.js, which can be found in the Power BI client. And these are the functions that they use in order to display the pop-ups and the dashboards in their applications. Also, something to consider is that on their server side, they generate the tokens for the Power BI reports every 25 minutes. And this is done with the following code. And before I go, I wanted to give you a couple of resources for you to get started with Power BI APIs and also the Autodesk Forge APIs. We have a couple of resources in regards to the different tutorials that Microsoft has to offer in order to get started with the Power BI REST APIs and their JavaScript API. At the same time also, we have some Autodesk Forge examples that we have created in the past, like the one that I show you with the Clash reports interacting with the Power BI reports. And at the same time also, we have some samples that you can find in GitHub in order to get more interaction with embedded viewer containers inside of the Power BI tool. And that will be it for today. Thank you. My name was Jaime Rosales, and I hope you guys found this class exciting. Until the next time.